the story of the universe, from the Big Bang to the end of time. In the beginning, there was nothing, no stars, no galaxies, no light. Then, from a single spark, everything was born. Stars ignited, worlds collided, black holes swallowed light itself, and across billions of years, the universe wrote its story. This is that story, from the birth of time to its inevitable end. Welcome to the story of the universe. The birth of stars, cradles of creation. Imagine a silent, endless universe, no stars shining, no light piercing the void, only darkness. But in that silence, something extraordinary is about to begin. Far away, massive clouds of gas and cosmic dust slowly gather. They are called nebulae, the true cradles of the cosmos. Here, stars are born. The power of nebulae. Nebulae aren't ordinary clouds. They are filled with hydrogen and helium, the raw building blocks of the universe. For millions of years, they drift quietly through space until something awakens them. A nearby supernova explosion or the pull of a passing star shakes the cloud, disturbing its balance, and suddenly, gravity takes over. The giant cloud begins to collapse in on itself. Collapse and pressure. As gravity squeezes the gas and dust tighter and tighter, molecules collide, the temperature rises. At the very heart of this collapse, a tiny spark of creation forms, a protostar. It's like a cosmic newborn, still hidden in its cocoon of gas and dust. It doesn't shine yet, but deep inside, pressure and heat continue to build. When the core reaches about 10 million degrees, something magical happens. Nuclear fusion ignites. Hydrogen atoms fuse into helium, releasing an unimaginable burst of energy, the birth of a star. And then, in the heart of darkness, light finally breaks free. A new star is born. It will shine for millions, sometimes billions, of years, warming, illuminating, and shaping everything around it. Around some stars, planets will form. On rare ones, life may emerge. The eternal cycle. Every star you see in the night sky, every twinkling point of light, was born this way. The breathtaking Orion Nebula, the pillars of creation in the Eagle Nebula, are living nurseries where countless new suns are still coming to life. Even our sun was born like this, around 4.6 billion years ago, inside a giant cloud of gas and dust. That means every atom in your body, every breath you take, was once part of a star. We are, quite literally, children of the stars. When a star is born, it's not just a new light in the sky. It's the beginning of a story that may one day lead to planets, to oceans, to life itself. And perhaps one day, that life will look up at the night sky and wonder, where did I come from? The answer is simple. We are all made of stardust. Relax, close your eyes, and let the story of the stars guide you through the universe. If you enjoy cosmic journeys like this, don't forget to like, subscribe, and share. Black holes, the cosmic abyss. In the vast silence of the universe, there exist cosmic monsters, enigmatic regions of space so powerful not even light can escape them. They are the black holes. Born from the death of massive stars, black holes are nature's ultimate paradox, both creators and destroyers, sculptors of galaxies, and guardians of cosmic secrets. When a star many times heavier than our sun runs out of fuel, its core collapses under its own gravity. The explosion we know as a supernova gives birth to a black hole, an invisible abyss in the fabric of space-time. At the edge of every black hole lies the event horizon, the point of no return. Once something crosses it, be it a planet, a star, or even light itself, there is no escape. But what lies beyond this horizon? Is it endless destruction or a gateway to something else? The truth remains hidden, cloaked in the mysteries of physics. Inside, gravity becomes infinite, compressing matter into a point of unimaginable density, the singularity. Here, the known laws of physics break down, and reality itself may dissolve. Yet, black holes are not just destroyers, they shape the universe. At the hearts of most galaxies, including our own Milky Way, lurks a supermassive black hole, millions, even billions of times more massive than our sun. These cosmic giants may have played a crucial role in the formation of galaxies themselves. Even stranger, black holes might not be eternal. According to Stephen Hawking's groundbreaking theory, they can slowly evaporate over unimaginable timescales, fading away in a whisper of radiation. For centuries, humans have looked up at the night sky, wondering about our place in the cosmos. Today, black holes push those questions further, challenging our understanding of space, time, and reality itself. Join us on this journey into the abyss. Subscribe, and let's continue exploring the darkest, most mysterious corners of the universe together. Galaxies, islands of the universe. In the vast silence of the cosmos, scattered like jewels across the darkness, lie the galaxies, immense islands of stars, dust, and mysteries. Each galaxy is a universe within itself, home to billions, sometimes even trillions, of stars. Some spiral with elegance, their arms stretching gracefully outward, while others are massive, chaotic clusters, glowing with violent energy. Our own Milky Way is just one of these countless islands, yet to us it is everything. Stretching 100,000 light-years across, it is home to our sun, our planets, and every human story ever told. But the Milky Way is not alone. Neighboring galaxies like Andromeda drift closer each day. In 4 billion years, Andromeda and the Milky Way will collide, merging into one colossal galaxy, a cosmic dance that will reshape the night sky. Some galaxies are nurseries, birthing new stars in radiant clouds of gas and dust. Others are graveyards, where ancient stars have burned out, leaving behind black holes and remnants of cosmic time. Then there are the giants, elliptical galaxies containing trillions of stars, and dwarf galaxies, tiny companions that orbit their larger neighbors. At the heart of almost every galaxy lurks a supermassive black hole. In our Milky Way, it is called Sagittarius, a star. Invisible to the eye, yet unimaginably powerful, it anchors the stars in their cosmic dance. Galaxies are not isolated. They form clusters and superclusters, weaving together the grand architecture of the universe. The largest structures ever discovered are walls of galaxies, stretching hundreds of millions of light-years, shaping the cosmic web. And yet, for all their magnificence, galaxies are fragile. They can collide, merge, or even be torn apart by gravity. Their stories are written across billions of years, beyond the scale of human imagination. When we gaze at the night sky, every faint glow, every tiny speck, is not just a star, but an entire galaxy, each one with its own suns, its own worlds, and perhaps its own life. Galaxies remind us of the vastness of creation and our small but precious place within it. Join us on this journey into the abyss. Subscribe, and let's continue exploring the darkest, most mysterious corners of the universe together. Nebulae, the cosmic nurseries. Far away in the silent void of space, clouds of gas and dust drift like ancient spirits. These are not ordinary clouds. They are nebulae, the great nurseries of the cosmos, where stars are born and where others meet their final fate. The birthplace of stars. Nebulae are vast, stretching across light years. Within their colorful clouds, hydrogen atoms collide, gravity takes hold, and sparks of creation ignite. From these glowing cradles emerge new suns, each one a beacon in the infinite dark. Our own sun, billions of years ago, was once a child of such a nebula, a cosmic palette. When telescopes gaze at nebulae, we see breathtaking shades of red, blue, green, and violet. These colors are not just beauty. They are the fingerprints of cosmic chemistry. Oxygen glows green, hydrogen burns red, while dust scatters starlight into blues and purples. Every nebula tells its story through light. Types of nebulae. There are many kinds of nebulae. Emission nebulae glow with the energy of nearby stars. Reflection nebulae shimmer faintly, like cosmic mirrors. Dark nebulae hide stars behind curtains of dust, casting shadows across the galaxy. And then there are planetary nebulae, not worlds, but the final size of dying stars, their outer layers cast into space. The tragedy of supernova remnants. Sometimes nebulae are born from destruction. When a massive star explodes in a supernova, the debris spreads across the galaxy. These remnants, like the Crab Nebula, are the echoes of violent death, but also the seeds of new creation. From the ashes of stars come the building blocks of planets, life, and future suns. The Orion Nebula. One of the most famous is the Orion Nebula, visible even to the naked eye from Earth. Just 1,344 light-years away, it is a stellar nursery filled with thousands of young stars. To look at Orion is to look at cosmic childhood, stars just beginning their journey. The cycle of creation. Nebulae remind us that the universe is never still. Matter is recycled endlessly. Old stars die, their gas and dust return to the void, and from that void, new stars rise. In every nebula, we see both an ending and a beginning. Perhaps one day, as humanity looks deeper into these glowing clouds, we will find not just the story of stars, but the story of ourselves. For the iron in our blood, the oxygen in our breath, the carbon in our cells, all once lived in the heart of a star, born from a nebula. Narrators whisper, nebulae, the womb of the cosmos. From their glowing embrace, life itself began. And if you enjoyed this journey among the stars, don't forget to like the video, subscribe to the channel, and join us for more cosmic stories. The universe is vast, and together we'll explore it. The death of stars, from giants to neutron stars. Every star is born in a cosmic cradle, and every star must one day face its inevitable end. The story of the death of stars is not one of silence, but of cosmic fireworks, violent collapses, and transformations so powerful they reshape the universe itself. Welcome to the final chapters in the life of a star. Stars, like all living things, have life cycles. Small stars, like our sun, live long, quiet lives, burning their hydrogen slowly. But when the fuel runs out, the star changes dramatically. When small to medium stars reach the end, they shed their outer layers into space, creating beautiful planetary nebulae, glowing clouds of gas that expand across light years. At the core, what remains is a white dwarf, a dense, Earth-sized ember, the fading heart of a once mighty star. But giant stars, their fate is far more violent. They live fast, burn bright, and die young. When their fuel is gone, gravity wins. The core collapses in a heartbeat, and the star explodes in a supernova, one of the most powerful events in the universe. In that explosion, elements heavier than iron are forged: gold, silver, uranium, the building blocks of planets, of life, of us. We are quite literally born from the deaths of stars, and at the heart of some supernova lies a remnant unlike anything else. If the star is massive enough, its core collapses into a neutron star, a city-sized sphere with the mass of the sun, spinning at incredible speeds and emitting beams of radiation like a cosmic lighthouse. And if the star is even more massive, the collapse continues. The core falls inward, beyond comprehension, beyond escape, into a black hole, the ultimate death, and perhaps the ultimate mystery. The death of stars is not just an end, it is a beginning. From their ashes, new stars are born, new planets form, and life itself becomes possible. The cosmos is a cycle of creation and destruction, a balance written in the stars. So when you look at the night sky, remember this: every star you see is writing its own story, and one day it too will die. And when it does, it may give birth to worlds yet unseen. If you want to keep exploring the mysteries of the universe with us, don't forget to subscribe to the channel. The cosmos is vast, and our journey has only just begun. Dark matter, the invisible force of the cosmos. Imagine a universe filled with invisible hands, shaping galaxies, guiding stars, and weaving the very fabric of reality itself. Yet, we cannot see them. We cannot touch them. We can only feel their pull. This is the story of dark matter, the unseen architect of the cosmos. For centuries, we believed we understood the universe: stars, planets, gas, dust, everything we could see and measure. But then, something didn't add up. Galaxies were spinning too fast. If visible matter were all there was, they should have torn themselves apart long ago. Yet they held together, bound by something unseen. Scientists realized most of the universe is missing from our eyes. Nearly 85% of all matter is invisible. We named it dark matter, not because it's dark, but because it hides from light. It doesn't glow, absorb, or reflect. It passes through us, through stars, through entire galaxies, like a ghost. Astronomers search for its clues through the bending of light, gravitational lensing, where distant starlight warps around massive invisible halos. Across billions of light years, dark matter forms a vast cosmic web, an invisible skeleton on which galaxies are built. Every cluster, every spiral, every twinkling light exists where dark matter once gathered. Without it, there would be no galaxies, no stars, no us. We've mapped its effects. We've measured its pull. But what is it? Nobody knows. It could be undiscovered particles, WIMPs, axions, or something far stranger. It could even mean our laws of gravity are incomplete. Every night, telescopes around the world search the sky for a flicker, a trace, a whisper of something we cannot see. But that defines everything. Dark matter remains one of the greatest mysteries of existence, unseen, untouchable, yet essential. Perhaps one day we'll uncover its true nature and finally understand the invisible threads that bind the universe together. Until then, we keep searching into the dark. If you enjoyed this journey into the unseen cosmos, don't forget to subscribe for more cosmic mysteries. The Big Bang, birth of everything. In the beginning, there was nothing, no stars, no galaxies, no time, no space. An infinite silence stretched across an endless void, a silence so complete it defied imagination. And then, from this absolute nothingness, came everything. Scientists call it the Big Bang, not an explosion in space, but the birth of space itself. It happened nearly 13.8 billion years ago, in a fraction of a second smaller than you can comprehend. All the energy, all the matter, all the forces that would one day form stars, planets, and even you were compressed into a single, unimaginably dense point. Then, in an instant, it expanded. Space began to stretch. Energy rushed outward. The universe was born. In the first trillionth of a second, the infant cosmos was a storm of chaos, a boiling sea of energy and particles, colliding and transforming in ways no human mind can truly picture. Gravity, electromagnetism, and the nuclear forces took shape, defining how the universe would behave forever. As the universe expanded, it cooled. Protons and neutrons began to form, joining together into the first atomic nuclei. Just minutes after the Big Bang, the first elements, hydrogen and helium, appeared. There were no stars yet, no light as we know it, only a glowing fog of particles. For nearly 400,000 years, this fog filled the universe. But as the temperature dropped, those particles combined to form neutral atoms, and light was finally free to travel. That ancient light, the cosmic microwave background, still glows today, a faint whisper from the dawn of time. The darkness that followed lasted for hundreds of millions of years, an age astronomers call the Cosmic Dark Ages. The universe was vast, silent, and empty. Yet in the shadows, something extraordinary was beginning to stir. Gravity slowly pulled clouds of gas together. They swirled, compressed, and ignited, forming the very first stars. These were not like the stars we see today. They were enormous, hundreds of times more massive than our sun, and burned with ferocious intensity. Within their blazing hearts, new elements were forged: carbon, oxygen, nitrogen, iron, the building blocks of everything that would come after. When those first stars reached the end of their lives, they exploded in titanic supernovae, scattering their enriched matter across the cosmos. From those ashes, the first galaxies began to take shape, vast cities of stars and dust spinning in a cosmic ballet. Over billions of years, they formed clusters, superclusters, and the immense cosmic web that stretches across the universe today. Among the swirling stars, countless planets began to form, some barren, some covered in oceans, some destined to cradle life. One of those small, fragile worlds would orbit a yellow star in a quiet corner of the Milky Way. And there, billions of years later, life would open its eyes and look back into the darkness, asking the same question that began it all. Where did we come from? The answer lies in that first flash of creation, in the expansion that still continues even now. Every second, the universe grows larger. Galaxies drift apart, time stretches, and the echo of the Big Bang hums softly in every direction. Everything you see, everything you are, was once part of that first spark. A moment when energy became matter, when chaos became order, when nothing became something. You are made of stardust, atoms forged in the heart of that primordial fire. The iron in your blood, the calcium in your bones, the oxygen you breathe, all were born in the stars, and those stars were born from the Big Bang. The universe is not a place you simply live in. It is a story, one that began long before Earth, long before light itself. And though billions of years have passed, that story is still being written, one heartbeat of a galaxy at a time. From nothing came everything, and one day everything will return to silence once more. But until then, the cosmos continues to expand, evolve, and dream through us. Exoplanets, other worlds, beyond our sun, far beyond the gentle warmth of our sun, lies an ocean of stars, each one blazing with its own light, each one possibly home to worlds we've never seen. For centuries, we looked up at the night sky and wondered, are we alone? But for most of human history, the idea of other worlds was just a dream, a whisper of imagination. That changed in 1995, when two Swiss astronomers, Michel Mayor and Didier Queloz, made a discovery that shook astronomy forever. Orbiting a distant star called 51 Pegasi, they found the very first confirmed exoplanet, a planet outside our solar system. They called it 51 Pegasi b, a world unlike anything we'd ever known, a giant gas planet, larger than Jupiter, orbiting so close to its star that a year lasts only 4 days. This discovery opened a new chapter in our understanding of the universe, a realization that planets are everywhere. As our technology improved, telescopes like Kepler, TESS, and now the James Webb Space Telescope began to uncover thousands of these hidden worlds, each with its own story. Some are gas giants like HD 189733b, where the skies rain molten glass sideways at 7,000 kilometers per hour. Others, like Kepler 22b, orbit peacefully in the so-called habitable zone, the sweet spot where liquid water could exist. And then there are the strange ones, rogue planets that drift endlessly through the darkness with no star to call home. Imagine standing on one of these alien worlds, a red sun rising over a violet sea, moons the size of Earth hanging in the sky, gravity pulling at your feet, the air thick with unknown elements, the silence absolute. Each exoplanet challenges what we thought we knew about how planets form. Some have two suns, rising and setting together, like in a scene from Star Wars. Others orbit dying stars, feeding on the last whispers of light. But the question that drives us most is not how many there are, It's what might live there. Scientists search for biosignatures, hints of life hidden in the colors of a planet's atmosphere. Oxygen, methane, water vapor, the chemical fingerprints of biology. And when James Webb points its golden mirrors toward these distant worlds, it doesn't just see planets, it sees possibilities. Maybe somewhere, orbiting a quiet sun in another galaxy, there's a blue world, lush, alive, waiting to be found. A planet where oceans shimmer beneath alien skies and life, in some form, thrives. We are still at the beginning of this grand journey. Every new discovery brings more questions than answers. But one thing is certain: the universe is not empty. It's teeming with worlds, strange, beautiful, and countless. We are the explorers, standing at the edge of infinity, looking out and wondering which of those distant lights might be looking back. If you enjoyed this journey among the stars, don't forget to subscribe, because the next chapter of our cosmic adventure is just beginning. The end of the universe, fate of everything. The universe, vast, ancient, and ever-expanding. But what happens when everything, every star, every planet, every atom, reaches its end? This is the story of the universe's final destiny. It began nearly 13.8 billion years ago with a single flash, the Big Bang. From that explosion of light and time, galaxies were born, stars ignited, and planets took shape. But even creation carries within it the seed of destruction. Everything that begins must one day end. As we look to the night sky, we see eternity. Yet in truth, we are watching ghosts, light from stars that may already be gone. The universe is not timeless. It is a clock ticking slowly toward silence. In the distant future, billions of years from now, the Milky Way will collide with the Andromeda Galaxy. Two great spirals of stars merging in a cosmic dance, beautiful and violent. Black holes will consume the centers, stars will be thrown into the void, and from chaos, a new galaxy will be born. But even this rebirth cannot last forever. Over trillions of years, stars will burn their last fuel. One by one, they'll fade into cold remnants, white dwarfs, neutron stars, and black holes. The once bright universe will grow dim until only darkness remains. This is the era of black holes, a time when gravity rules and light itself struggles to exist. Galaxies vanish, planets are torn apart, black holes devour all that remains, even each other. And when they finally evaporate through Hawking radiation, not even they will survive. All that will be left are subatomic whispers, particles drifting endlessly through a frozen cosmos. A temperature so low, even motion will die. No stars, no galaxies, no heat, no light. Only the dark remains. Scientists call this the heat death of the universe, the moment when entropy reaches its absolute maximum and energy can no longer flow. It's the end of change, the end of time itself. But perhaps endings are never truly the end. Some theories suggest that after this silence, the universe might be reborn, a new Big Bang emerging from the ashes of the old, a cycle of creation and destruction repeating endlessly, forever expanding, forever beginning again. Maybe the universe doesn't end. Maybe it simply dreams, breathing in and out across eternity. And so, as we gaze into the night sky, we are not just witnessing the past, we are glimpsing our own destiny. A reminder that even in the face of cosmic finality, existence itself is the greatest miracle. The stars may one day fade, but the story of the universe and our place within it will never be forgotten, because we are made of that same light, and in that light, we are eternal. Subscribe for more journeys through space, time, and everything beyond. Stay curious and never stop looking up.